The remainder theorem, here's our given information for the remainder theorem. F of x is a polynomial function not a whole lot of given information there, right? The polynomial function that we just looked at, for example, on the board, f of x equals x to the fourth minus 256. That's a polynomial function. If we just change it from an expression, we set it equal to y, or in this case, f of x function notation, then we have a polynomial function. And what do we know about that polynomial function? What did we just discover? It has 4 solutions. We found all 4 of those solutions using synthetic division and specifically the remainder theorem. Okay. Now, if y'all just stay with me because there's some algebra speak here. Here's our given information. F of x is a polynomial function. We don't know anything more specific than that. We don't really need to for the remainder theorem. If f of x divided by x minus a because this is a remainder theorem, we're going to make assumptions based on what the remainder is. Has a remainder of 0. If when you divide f of x by x minus a, you get a remainder of 0. Not zero. 0. Then we know 2 things. At least 2 things. The first of all, we know that x minus a is a factor of f of x. If it has a remainder of 0, then x minus a is a factor of f of x. Okay, and the other thing we know, a, the root of our divisor, is a root of f of x. So if we're doing synthetic division and we get a remainder of 0, we have some really powerful information that we can use. The 4 gave us a 0 when we were working with f of x equals x to the fourth minus 256. 4 gave us a 0, negative 4 gave us a 0. That tells us that 4 and negative 4 were roots of the polynomial. Okay, and it tells us that x minus 4 and x minus negative 4 were both factors of the polynomial, and they were indeed when we looked at the factorization. Okay, so we're going to kind of use synthetic division to evaluate using specific numbers, and we're going to use the outcome of those specific numbers to tell us whether the value is a root or not, whether x minus that value is a factor of the expression or not. Okay, so if f of x divided by x minus a has a remainder of 0, then x minus a is a factor of the polynomial function, and a is a root of the polynomial function. Okay, so when we get 0 as a remainder, we found a special number. All right, here's the other condition. Now, what would the other condition be, you think? What if f of x divided by x minus a does not have a remainder of 0? We're going to be a little bit more specific because we're really only going to be interested in rational values. We're just going to consider it if it's a rational number. Okay, if f of x divided by x minus a has a remainder of q, where q is just a rational number. Now, what I'm about to tell you is not specific to rational numbers, but we're just going to consider rational. We're not really interested in irrational and imaginary values that might come out of this process. But if it has a remainder of q, where q is any rational number, all right, then a is not a zero. It's not a root. Okay, but f of a, in other words, the function evaluated at a, is equal to q. All right, so AQ, where x is A, y is Q, is a point on the graph of f of x. And we mentioned that yesterday. If you evaluate a function at that root of the divisor, the output is the function evaluated at that root. Okay, so it's a useful skill for us, but it's most useful for doing investigation in order to find the zeros, because the zeros, the roots, the special numbers are the ones that we're looking at. Okay, but just, this is more practice, guys, with using synthetic division to accomplish another purpose. Who's got the homework set? Page 350 is where we're going to be looking. So you guys grab your homework set out there, page 350. And let's look at a couple of example problems down at the bottom. Look at problem number 36. Somebody read that to me.
F of x equals 4x cubed plus 5x squared minus 6x minus 4, and the f of x is negative 2.
So what they're telling us to do is to find f of negative 2. And we're going to find it using the remainder theorem. Okay, so to use the remainder theorem, we're saying that this is our a value, negative 2. And we're going to use 4x cubed, 5x squared, negative 6x, negative 4. Bring down the 4. And then we're going to do the synthetic division process to find the remainder. What we're interested in here is the remainder. So that would give us negative 2 times 4 is negative 8. Negative 2 times negative 3 is 6. All right, positive 6 and negative 6 is 0. That gives me 0 here. Remainder is negative 4. That means this is negative 4. Now, is that a viable option for finding f of negative 4? Couldn't you have just plugged it in? All right, what would that look like? F of negative 2 equals 4 times negative 2 cubed plus 5 times negative 2 squared minus 6 times negative 2 minus 4. Now, if you don't have a calculator handy, which method do you want to use? Synthetic division, right? There's a lot more operations involved here than doing this process. Agreed, right? I mean, it's kind of a slick thing, and it's really it's kind of almost magic if you think about it, right? Listen. What we're actually doing when we evaluate this synthetic division process here is we're doing 4 times negative 2 cubed plus 5 times negative 2 squared minus 6 times negative 2 and then subtracting 4. all of these operations in this bottom thing down here are encapsulated in this process. And that's pretty cool. Every single time. Every single polynomial. So whoever stumbled upon the remainder theorem as it relates to polynomial division stumbled onto something pretty big. Okay, let's do another one. That was number 36. Let's do 39. No, that's a fraction, isn't it? Yeah. I'm going to leave that one for you for homework. Let's do 37. 37 is f of x equals what?
X to the 4th plus 5x cubed plus 5x squared minus 5x minus 6. And the x is 3.
Find f of 3. Now keep in mind, you could do 3 to the 4th plus 5 times 3 cubed plus 5 times 3 squared minus 5 times 3 minus 6. The synthetic division process is just arithmetic, multiplication, and addition, right? So that's 15. And now granted, the numbers can get large. No, 3 times 1 is not 15. Not even on Wednesdays. 3 times 1 is 3. That's 8. 3 times 8 is 24. That's 29. 3 times 29, 60 plus 27 is 87. That's 82. 3 times 82 is 246. So my remainder here is 240, which means f of 3 equals 240. Not 0. Okay? But we do have a fact here. The point where x is 3 and y is 240, that point is on the graph of that function. It's usable information. Not that we want to get that large, but it just kind of gives you some idea of what this function is doing to numbers. They're getting big pretty quickly, right? 3 is already at 240. Okay? Let's take this same function and find f of 1. Oopsie. Let's find f of 1. And I have the ability to do this. This would be kind of where it'd be nice to have a whiteboard. You could just kind of erase things. And f of 1. 1, 1, 6, 6, 11, 11, 6, 6. What'd you get there? What does that tell us? What does that tell us? That 1 is a root and x minus 1 is a factor. X minus 1 is a factor of f of x. As a matter of fact, f of x is equal to x minus 1 times x cubed plus 6x squared plus 11x plus 6. Now, how does that help us? In our ultimate goal in algebra to find the n solutions to an nth degree polynomial, I've found one of them, and I've reduced my problem. Now I only have to find 3 more zeros to be complete. And then I've got it. Right? Okay. Now, I just pulled this number right out of thin air. I guessed at 1. I haven't worked this problem before, but the 1 actually worked. Okay. And what we're going to talk about tomorrow is which numbers to guess. Which numbers should we try? Okay. And we'll learn some other things, like we'll learn that imaginary solutions always come in pairs. Right? We've already talked about that. Plus or minus the square root of something, it'd be imaginary. They're conjugate pairs, so we know that this thing has 1 more real solution or 3 more real solutions that we can find. Maybe they're rational numbers, maybe they're not. We'll work on that kind of thing tomorrow. Okay? But what we're going to do today is just practice the skill of using the synthetic division process and the remainder theorem to find these points. Okay, tomorrow we're going to be specifically targeting, looking for these points, the ones that give us 0 in the process. Okay, now your homework from this lesson, and I know it's Wednesday, we don't give homework, so you'll be able to finish this in about 5 minutes. I want you to do 33, 34, 38, and 39. When you said that, I thought, well, have we already done that? And all you're going to be doing in this process is using synthetic division and the remainder theorem to find the solution. Okay?